Okay, so now for lecture 2, we want to delve a bit into this value type and see how we can work with it in OpShin. So to start with that, let's just actually first have a look here at the OpShin ledger API definitions. So this is just the part of OpShin that kind of defines the script context and all the necessary types that are involved in it. So yeah, we see here like all this transaction output, reference, pub key, and so on. And one thing we see here is the value type, and we can directly see how it is represented. So here the type is that it is a dictionary from mapping from policy ID to another dictionary, which itself is mapping from token name to integer. Okay, so why is it like that? So first of all, we can see like policy ID and token name are simply a wrapper for a bytes string. So each native token consists of a policy ID and a token name. So the policy ID kind of, and we will see this later, represents the policy under which it can be minted. And then we could actually mint from the same policy ID tokens with different names. And yeah, this will also become more clear in later lectures. But this is simply the structure of native tokens. And so then I guess it makes sense that so first of all, a value should support having many native tokens potentially. And because we have this kind of split into these two names, let's say, we just take the policy ID, then we map to all of the different token names that are contained in this value. And then for each of them, there could be a certain quantity. So this is then represented just by the integer. So yeah, so let's say the value would just be Ada. So actually the Lovelaces are represented in Cardano with the empty string for both the policy ID and the token name, which also makes sense because there will be no policy under which we can mint Ada. And let's say a value would just contain Ada, then it's simply mapping. Basically the only key in the dictionary here is the empty string, and this would map to the value, which is the dictionary, which also has only the empty string and the integer, which is the respective amount of Ada. Okay, so this might seem a bit abstract, so let's actually go back and get our hands on it. So we'll just run through a couple of examples that we have here. And so I'm here in the console, and to make this work, we need to make sure we have the right Python environment that has this that has the OpShin installed. So yeah, you just do the poetry install. I've already done this, so I will just go directly into the poetry shell and then launch a Python shell there. And within this, just make sure to import these functions that we will be using now. And then also the OpShin prelude, we import everything. Okay, so now the first example is simply to define a token. So here, yeah, we just use this token class to construct a token object, and the first argument here is the policy ID, and the second one the token name, which we have to give as a bytes object. so if we do this, then we create the object, and if we look at it, okay, now we have a token with this policy ID and this name. Okay, so note that this is a token, right? So it's not a value. The value would consist of this mapping we just saw that could contain multiple different kinds of tokens and the amount of them. So this is what we do next. So this function basically has two arguments. You give it a token and you give it an integer, and it gives you back a value that has exactly this amount of token of type T1. So if you look at it, we see exactly this kind of nested dictionary structure that I just explained. So we have under the policy ID P1, we have only one token name, namely this T1 that we defined, and we have seven of those. And maybe just to understand a bit better, it's also actually interesting to look at this function. So it comes here from week 5 lecture, and then I guess this is under value utils. So maybe let's just see what it does. Yeah, exactly. It takes a token, takes amount, and returns a value. And the way it's done is simply, okay, we just need to construct this dictionary that value is a wrapper for. So for the dictionary, yeah, we just take the policy ID and we exactly map it to this other dictionary that goes from token name to the amount we gave. Okay, the next function that we use here is amount of token in value, and I guess the name is already saying what it does. So we give it the token type and the value we just constructed, and we expect it to give us the amount of tokens of type T1 in value V1, which is exactly 7. And yeah, let's maybe also look how it's implemented here. Amount of token in value for this token and this value. So we simply use the get method. So yeah, keep in mind that value is nothing but a dictionary in Python. So for dictionaries, you can use this get method to obtain the value of a certain key. And yeah, because it's this nested dictionary, you have to do it twice here. So first we get the value of under this token policy ID key. And then once we have this, we get the value under this token name key, which the value of that would then be the integer, right? And okay, we have the second argument here in the get method. This is just a default that is returned if no such key is available in the dictionary. And yeah, here it would make sense to just have basically a 0 then, because this token is not contained in the value. Okay, let's just play around a bit more with the values. So now we define a second token with a different policy ID P2 and different token name P2, and we put 42 of them into this value 2. And then here we have a simple function that adds two values. So let's construct a new value V3 that is the sum of V1 and V2. And then what do we expect to have in this token? Well, just the token T1 that we have in value 1 and the T2 we have in value 2, which is exactly the case, and yeah, the numbers here that we defined. And yeah, maybe just to see how now more value gets added, let's just add V1 again to V3. And since V1 had 7 T1s and V3 had also 7 T1s, okay, what is the amount of T1 we would expect in V4? well, it's just 7 plus 7, which is exactly 14 that we get here. And we can also subtract and we can also subtract and yeah, get the expected result. So maybe let's look quickly at the definitions of add and subtract value. So yeah, if you look here, essentially what we do in the end is we want to take all the policy IDs and then put as the value here the dictionary that has as key basically all the token names from both of the values and the respective values, the respective integers added together. So it's just a bit, yeah, you need to be a bit careful here, I guess, when implementing this, which you won't have to do, but let's just understand maybe on a high level what happens. So we have to add together the token names. And because the same token name might appear in both A and B here, we have to basically merge them together. So we get the list of token names in A and the ones in B, we merge them together, and then we add the amounts that we have in each of A and B. And these are just special cases for when the A or B is an empty dictionary. And yeah, so then we have added the token names together, and basically we put the policy IDs here, and yeah, again, we kind of make sure that there's no duplicates among the policy IDs, so that the value is represented in the simplest possible way. And subtraction would be implemented analogously. Yeah. And yeah, just to conclude, as we already mentioned, the policy ID, it's not just an arbitrary string, unlike the token name, which you can actually then later set to be an arbitrary string. The policy ID is different in that it actually encodes the minting policy by being the hash of it. And so when we will see minting policies later, it will be something like a script, like a smart contract that gives the conditions under which a token can be minted. And yeah, this script is basically invoked whenever you have a transaction that wants to mint a certain token. And yeah, as we said, Ada has a empty string as policy ID, which fits because it cannot be burned or minted in simple smart contracts. Okay, so now we have an understanding of how the value works, how we can operate with it, and we will next see how to actually mint tokens.